Hello everyone, this is Team 6 from CSCI599 at University of Southern California, Spring 2016. This video is to talk about content detection and metadata extraction analysis and evaluation of the extracted data for the TREC Dynamic Domain Polar dataset and the NSF Common Crawl dataset which was used during the entire course. So in this video we will give you a walkthrough of how we have evaluated the content detected as well as the metadata that was extracted during the analysis, as well as give you an explanation of the same. So first off, we would start with classifying the path from request to content via the response. So this was done for the CCA dataset, and this shows all the data that was returned by the response in addition to the request that was generated for each of the page in the dataset. So for this, we have considered 3 use cases as examined in the whole dataset. So one is the successful response returned by the server. So as you can see, these are some of the attributes that are present in the request as well as the response formats. So as you can see, the content type requested by the requester was of an MS Word file, and the response server returned of the same type. So which you can say that there is a content match as well as it is a successful request. Also, it returns the data in the body attribute of the response, as you can see over here. The second attribute that or the second use case that we have seen over here is of an unsuccessful request made to a server. So as you can see, the content types mismatch over here. Also, the HTTP status returned by the servers is a 404, which means that the resource or the requested page was not found on the server. Therefore, the content length in the response is of size 0. The third use case that we've considered over here is of a content mismatch. So as you can see, that although a page is returned by the server back to the requester, there is a mismatch of the content types. So as you can see, the requester requested for an application/JSON file, but the server responded with an XML file, and which gives you along the length of the response. Next up, we will check the file size diversity of the CCA dataset by MIME type. So in this analysis, we have computed the size ratio of the Solar index to the file size of the original data that we have. So as you can see, for the video MIME type, 20% of metadata was extracted as compared to the original file size, and as you can see, for text it's about 4%, for PDFs it's about 3%, for HTML and XML it's about 8%. So, but as you can see, for video MIME type it's close to 20%. This is because of specialized metadata content extraction tools available for extracting metadata out of the video MIME type, such as the XIF tool, as compared to the generalized content extraction methods for text-based MIME types such as PDF, text, and HTML, which use the tag ratio technique. Next up, we will check the parser called chain and how much text and metadata was actually obtained from the content extraction that we performed on our dataset. So as you can see over here, we used 4 parsers to extract data from the dataset provided to us. So first one was the measurement extractor. In the measurement extractor, the steps which were followed was that we first converted each and every file to its HTML equivalent using the Apache Kika libraries. Then we performed tag ratio algorithm on them to extract only the text and to segregate the non-tag ASCII characters from the tagged ASCII characters. And then we performed tokenization of each and every part of the text that we obtained from the tag ratio algorithm and performed a dictionary lookup to extract measurements from that. So as you can see, if we click on the tag ratio algorithm, we're able to see a flowchart for tag ratio, which starts from removing the HTML script styles and CSS tags to removing the HTML tags and getting the required text from the tags and store the text inside a text file. Similarly, you can check up for the other tokenization and this dictionary lookup as well. So this is the flowchart for that, and these are the steps which are followed to extract and compare with the dictionary all the tokens that we obtained from it. So next up, we check that the amount of text retrieved per file size per MIME type, as well as the amount of metadata retrieved per file size per MIME type. So as you can see, we created a Circos D3 visualization for this. The outer periphery of the circle over here determines the MIME type or the file type of each of the data that we have. And as you can see from the key, this shows the second inner periphery shows the contribution of each of the parsers in extracting that much amount, the amount of metadata for that kind of file. So as you can see, in the text files or in Excel, in MS Word, in PDF, the contribution for the measurement extraction is quite significant. And also a lot of ontologies, the suite ontologies were extracted in the same. And as for the application/octet stream file type goes, the suite ontology and the Grobit parser had significant contributions for that as well, which shows that there were a lot of papers with references to suite concepts, and there were a lot of publications with reference to a lot of authors and their affiliated publications, which show that a lot of scientific data was available regarding the polar regions, and a lot of awareness was being created regarding the same. So one important aspect comes up while analyzing these files in the dataset is in what language are they present. Are they available for the whole audience of the world to interpret and to understand? So we performed a language identification analysis on all the files in the polar dataset, and as you can see through this pie chart, we made a language diversity analysis chart for this, and as you can see, there is a contribution of the English language the most, which tells us that most of the documents in the polar dataset that we had were in English. Around 60% of the data was in English. Around 3.8% of the data was in Italian. Some of it was in Estonian. Some of them were in Russian. And what we observed was on file types or on data that it could not, Apache Tiga could not identify the language of the data, it tagged it as Lithuanian. So as you can see, there's a lot of files which have been tagged with the Lithuanian language, which on manual observation we checked were files which could not be interpreted or were not in the English language. So in order to find exact patterns into the data that we analyzed, we needed to find terms which are occurring more frequently than other terms in the data set. So we chose all the suite concepts that we extracted through our suite ontology extractor and made a word cloud, D3 word cloud visualization of the same. And as you can see through this visualization, that there are some terms which occur more frequently into the data and which are represented by larger fonts. So as you can see, there is a lot of mentions for Arctic, for Pacific, for management, for human activity, for the location. So which tells us that there has been a lot of human activity, references to human activity, a lot of references to the Arctic, which is related to the polar regions, related to North, and related to research, and we found a lot of these references in the data that we have occurred with us. So as you can see, that this gives you a fair idea of all the terms, and it also gives you a fair gist of the topics that were covered during the files or the papers that were published with this polar data set. Now, in order to have a proper agreement between the data that we extracted with our techniques as compared to the other toolkits that are available, we needed a standard so that we can compare our data with the data extracted by other toolkits. So we used 3 other toolkits which were used for named entity recognition, and compared our measurement extraction, our suite ontology extraction with what the other toolkits extracted. So this visualization shows some of the topics or some of the terms that were detected by all the 4 NER toolkits that we've used. So we've used Global Quantities, we've used OpenNLP, we've used the Stanford Core NLP, and we've used the NLTK NER. So as you can see in this, there are a lot of terms, a lot of measurements in which agreement is maintained between all 4 of them. There are some cases in which agreement is not reached for some of the terms identified by the other toolkits as well, which is quite understandable, as no toolkits are perfect for analyzing, and each toolkit has its own model on which it is trained and will give you different tags for different kinds of data which is extracted from. Next, we identify the spectrum of measurements that were occurring in our data set. So first up, we check it with respect to each of the MIME types, that is for video, for text, for PDFs, and for other types of files. And then we will see something for the top level domains from which data was extracted in our data set. So for a type of video, we can check the time frequency, we can select a particular measurement, and we can check its maximum, average, and the minimum values that were occurring. And all these values are scaled on a ratio of 1:1000. So each of these values moves up from 0 to a value of around 225. Similarly, we've done the same with respect to a top level domain. You can go deep into this hierarchy, find out measurement functions, and find out their maximum, average, and the minimum values with respect to each measurement mentioned in each of the domains. So this was about it for the analysis and the evaluation of content detected and the metadata extraction that we performed for each of the data in the data set. So in conclusion, we would like to say that the common crawl architecture was useful in studying how the request and response process goes about. Also, Apache Tika's NER integration with all the 4 toolkits that we decided and the 4 toolkits that we mentioned, which provided valuable insights into our analysis of the metadata. And each parser has been scored as a percentage of metadata extracted over the MIME types, which make it clear that ontology extraction and measurement extraction were the more powerful tools that we used in our content extraction. We also made the score dependent on the type of data set on which the analysis was carried out. So it was always good to go through the data set to look at the data that is relevant, like measurements, publications, earth science concepts, and then choose relevant parsing techniques so that we could maximize the content extracted and also extract relevant metadata for the same, which was the main goal, since all of the files that we had in our dataset were unstructured, and our main goal was to make them structured, give them good annotations, and extract relevant and important scientific metadata from the data provided to us. Thank you.